Welcome to the ANSYS tutorial 1 by Manivel. My name is Manivel. In this tutorial, we are going to see the structural analysis of cantilever beam. Here we are going to take down a cantilever beam, and I am going to give a point load on the cantilever beam. How the cantilever beam is behaves under the loading condition is going to see in today's ANSYS tutorial. My beam is an I-section beam which has a Young's modulus of 200 gigapascal and Poisson ratio is 0.3. In ANSYS, you want to click run to run the ANSYS. The menu of the ANSYS will become. Here we need to select the preference menu first for all the tutorials. First click preference, choose what type of analysis we are going to do. We are going to check structural analysis, or we are going to use thermal or ANSYS fluid. In this tutorial we are going to use structural analysis, so I have clicked structural analysis and then OK. Next one is click preprocessor. In the preprocessor we need to define the element first. Click element and add element. Here are once again click add. The set of here menu will be displayed. A set of two things will be displayed. On that we need to choose a beam. Beam contain various nodal elements. On that we are going to create a 2 nodal 188 element. We can choose either of them, depends upon our requirement. We need to choose. In this tutorial I am going to use beam 2 nodal 188. Then click OK and close. Next one, I need to define the material properties next. Material property is mainly used to define the what type of material I'm going to choose for the beam. Here I'm going to choose Young's modulus as 2e power 5 is 0.3. This normally for a mild steel. Many type of materials we can able to choose, either aluminum or cast iron or copper. All we need to give its Young's modulus and Poisson ratio. It will be automatically defined, and then click OK and close. Next one, we need to choose the section. What type of section I am going to analyze. Here we are going to analyze a beam. So click beam common section. In the common section a set of various menus will be displayed. From this is in this tutorial we are going to use I section. So I have clicked the I section. First one, width of I section is we already know the width of the I section is 200 and the height is 150 and its thickness is 10. So with this 200, again 200, and W3 is 170 and thickness is 10 mm, and another thickness is also 10 mm and another is also 10 mm, and click OK. Now I have defined the material property and what type of section I am going to use also defined. Next one is, so in modeling menu, once click the modeling, it will be next is to create a key points. I need to draw a beam. For that beam I am going to create 2 key points in working plane. In active CS, in the active CS, so my key point number is 1. The first point is my origin point, so I will give 0 0 and then apply. And then second key point is 2, and especially the length is about 200, so with respect to x-axis, so with respect to x 200, remaining 2 or 0, because I'm going to take as a two-dimensional thing. So I have chosen with respect to x is 200 and then click OK. Next is to connect the two key points. My key points is displayed in my screen. Next is to click line and then again line, straight line, and then click the first key point and second key point. OK, I have created the beam line. Next one is to mesh the beam. Meshing. In the meshing, we need to take mesh tool, click mesh and OK. Auto mesh is generated. In upcoming videos, we will learn about how to control the size of meshing. Will be seen in the upcoming video. In this tutorial, I have chosen auto mesh, so automatically the mesh will be generated. Next step is to select solution. In the solution, we are going to define the loads. Define and apply structural displacement. In displacement, I am going to take, I have created key points now, so on key points, this is my first key point. Click OK. Once you click OK, the displacement means is a constraint kind of thing. What are all the things I am going to fix? In cantilever beam, the left side must be with respect to all degrees of freedom, it must be arrested. So I have clicked on all degrees of freedom. OK, a arrowhead will be displayed, so it is the constraint is created. Next is to I need to give a force on that right end of the beam. So I have clicked force on key points and then I have clicked the right end of the key point. OK, from that with respect to Fy, I'm going to give with respect to y axis I'm going to give my load. So with respect to y, and then whenever giving, you are going to give the value minus 100 means towards downward, plus 100 means towards upward. So here my load is towards downward, so minus 100. OK, and load is applied now. Next one is as solve current LS. OK, once you do done like this, the solution is done, must be displayed on screen. If you are not doing correct, it will not be displayed. Next, close this, go to general post processor and click plot results. On that plot results, contour plot, nodal solution. Here stress can be checked with respect to all those things. The DOF solution with respect to x, y, z displacement can be measured. Here I am going to choose y component displacement and then OK. The values will be displayed here. The red region indicates more amount of displacement, while the blue indicates somewhat in the safe zone. The red is a danger in zone. We need to reduce that values. Thus, next thing, we can able to animate this as analysis with the help of plot control, animate, model saves. Here we are having certain things, stress, strain, energy, all those things we can be done. Here I am going to choose DOF with the deformed shapes. OK, this is the displacement which we get from our problem. And close. That's all about the first tutorial. Thank you for watching this video. Thank you very much. Let us meet in our next tutorial. Thank you for watching this tutorial. Thank you very much for watching.